Alright, welcome back, guys. We're going to be looking at section 2.4 today, and this will actually conclude chapter 2, or any of the material from chapter 2 from the book. Okay, but we'll continue to progress before we have our first exam. But as you can see, 2.4 is on what's called the algebra of functions. This could just as easily be the arithmetic of functions. Okay, and there's a video link right here, and I put this in Blackboard as well. But it's a good example of a situation in which you might be interested in or would need to do some arithmetic with some different functions. Okay, so just like most real numbers, okay, we can add, subtract, multiply, and divide functions, and typically we'll get back, well, always we'll get back another function, and that other function can be very meaningful, guys. If you recall this lemonade example, you know, let's say you were thinking about creating a lemonade stand, but you want to be a bit analytical about it before you start, and so you try to figure out, well, you know, what material am I going to need to make the lemonade? I'm going to need some hardware. I'm going to need an actual stand and you know, a pitcher and things of that nature. Some cooking, well, maybe not cooking utensils, but some kitchen utensils nonetheless. And you figure out, you know, how much you want to charge per cup or per glass of lemonade, and then you can go on from there and try to figure out, well, if that's the case, how many glasses of lemonade am I going to need to sell before I start to see a profit? Okay, because initially you got to go out and buy all this stuff. You've got to make an investment, and it's only by selling in excess of a certain number of cups of lemonade are you actually going to make any profit. And so you can use functions to model things like the cost. How much are just the ingredients going to cost? What's the fixed cost? What am I going to be paying for the stand, the other kitchen utensils that I'm going to need? And you can create a revenue function that models how much you're going to make, or how much you're going to bring in, basically. That would be based on the number of cups that you sell times the price that you're charging per cup. And then once you have a cost function and a revenue function, you can subtract those two, and whatever's left is the profit. Okay, and so that would be an example in which all those functions are functions of x, or in other words, they're functions of the number of cups of lemonade that you sell. And so you can find what's called a break-even point. How many cups of lemonade do I need to sell such that I break even? Okay, or in other words, I don't lose money, but I also don't make any money. And then once you know that value, or that number of cups, then you try to sell more than that, you're going to actually start making some profit. So anyway, I just sort of recapped that video, but definitely watch that video. So anyway, we're going to be adding functions, subtracting functions, multiplying and dividing functions in this section. And guys, a lot of this you've actually already done, the mechanics anyway, in you know, classes prior to this one. Anytime you work with algebraic expressions, combining like terms, things of that nature, or multiplying, you were basically doing function arithmetic. Okay, and that's what we're going to look at today. Alright, well, we've got some definitions here. There's 4 of them. This just defines how we add, subtract, multiply, and or divide two functions. And we're going to be a bit generic about this. We're just going to refer to each of the two functions as f and g. Okay, but they could be any two functions. They could be h and k or whatever. Okay, so, and you'll have to pay attention to this notation here on the left. So on the left, when you see something like this, in parentheses, f plus g, and then out beside it, this x, this means function f plus function g added together. And the way you say this is f plus g of x. So you still use that function notation, okay? And then on the right-hand side, you can see this is how it's defined. You literally take f of x, or whatever function f is, and you add it to g of x, or whatever function g is, okay? And usually this is just going to involve a lot of combining like terms. And similarly for the subtraction, f minus g of x will be f of x minus g of x. And this is one you have to be a little careful with, because there's a minus sign here. And so if g of x has more than one term, you're going to have to distribute that minus sign, or that negative. And then similarly, guys, f times g of x is just f of x times g of x. This is typically when you have to do maybe some using that acronym FOIL, okay? You're multiplying two polynomials together. We'll see an example of this. And then finally, f divided by g of x is just f of x over, or divided by g of x. Now, lots of times you can't actually do any real division here, okay? Because f of x will be some polynomial, g of x will be some other polynomial, and you can't really divide them. But look at this condition: provided that g of x is not equal to 0. Do you guys remember that? We don't ever want that denominator to become 0, because then this overall function would become undefined. Okay? Remember from section 2.3. Alright, so let's try one of these. Example 1. And they will always give us our two functions, guys. F of x in this particular example is a quadratic function. It's x squared minus 1. And then g of x is a linear function. It is x plus 3. And we want to find two different things. We want to find f minus g of x. So in other words, we want to subtract these two functions. And then secondly, we want to find the product, or f times g of x. We'll want to multiply them. Okay, so this is kind of a two-part example. I'm going to zoom in a bit here. Get my water real quick. So the first thing I'm going to do is I'm going to actually write this notation out. F minus g of x is equal to, you can come back up here and look at your definition if you need to. F minus g of x is equal to just f of x minus g of x. Okay. Okay. And now what I'll do is I'll start substituting the functions in. Now guys, it's typically when you're substituting functions in and they have more than one term, you're going to want to keep them in parentheses. And so f of x is this quadratic function, so I'm going to write it in there, keeping it in parentheses. I'm going to carry over my minus sign, and then g of x, it has two terms, so when I plug it in, I'm going to keep it in parentheses as well. Technically, guys, you wouldn't have to keep the first function in parentheses here, but you definitely have to keep the second one. And the reason is because when we go to simplify this, we're going to have to distribute this negative. Okay. All right, so I'm going to get another color to actually show that. This is a nice pink here. Alright, so what I'll do is I'm just going to rewrite the first two terms of my first function. In fact, the first function I can just throw away or discard the parentheses at this point. I don't need them anymore. Okay, and then I'll distribute my negative right here, which is just going to make both of these terms negative. This will become a negative x, and that will become a negative 3 or minus 3. And I'm going to keep going. Okay. So once you figure out what you're trying to do with your two functions, a lot of this is just simplifying an algebraic expression. Okay, so now I've got 4 terms here, and I'm looking to see what can I do. Well, I cannot combine the x squared and the x, so those are just going to have to stay the same. Those are unlike terms. However, we do have a pair of constants. We have a -1 and a -3. -1 minus 3, guys, is a -4. Okay, and that's all we can do here. This ends up giving us another quadratic function. And I'm going to just restate this real quick, that f minus g of x is equal to this new quadratic function that we came up with. Okay. So thinking about the lemonade stand example, when you subtract the cost function from the revenue function, you're left with the profit function. Okay? And that new function is very interesting if you're going to be a business owner, right? It doesn't matter what the revenue is if you're not making any money. If the cost outweighs or exceeds the revenue, you're going to be the negative. All right, so that's the first part. We subtracted g from f. Now for the second part of this example, we're actually going to multiply these two functions together. F times g of x. Okay, so I'll use notation. Guys, when you're doing this, yourself, the notation's maybe not the most important part. The most important part is knowing what to do. Whether you're subtracting two functions, multiplying two functions, adding two functions, whatever the case may be. But because I'm a math teacher, I am going to be follow the convention here using proper notation. So f times g of x is equal to f of x times g of x. So that's what I'm going to write next. And now I'm just going to plug in my functions. So f of x is that quadratic again, x squared minus 1 times, and you can put a multiplication symbol here if you need to, but you don't have to, remember? And then g of x is that linear, x plus 3. Okay, so we're multiplying these two functions. And to multiply these, guys, you have to remember how to multiply two polynomials together. Okay, so when they're both binomials like this, or in other words, when each of these have only two terms, then you can use that acronym FOIL to think about the sequence of steps that you need to take: first, outer, inner, last. I don't like to use that acronym because it only works for multiplying two binomials. I think about it this way. I look at it like I'm going to take that first term, x squared, and I'll multiply it to both terms. Okay, and then after I've done that, then I'll move to my -1 right here and distribute it to both of these terms. If you look at it through the lens of distribution, then you don't have to ever remember any acronyms. Okay, so x to the second times x to the first. So if you guys remember, when you're multiplying, you have to add exponents. So that would become x to the third power. And then x to the second times 3 will just become 3x to the second, or 3x squared. Okay, so now I'm going to go to my second term, which is a -1, and distribute it to that second polynomial. Well, anytime we're distributing a -1, that's just going to cause our signs to change. So -1 times x will just be -x, and then -1 times 3 will become a -3. All right. Okay, so we've done the multiplication. Now we would look and see, are any of these terms like, or can I combine any like terms? And actually, guys, in this case, the answer is no. Every one of these terms is unlike, okay? And this actually turns out to be a cubic polynomial because it's got an x cubed. So we multiplied a quadratic times a linear, and we get a cubic function. So I'll just kind of restate here what we did. F times g of x is equal to this new cubic function. We're going to actually study these in more detail later on in the course. Alright, so there's you a couple examples in which you're just subtracting or multiplying two functions, and you get another function. Okay. Now let's move on to example 2, because what we've got here is we've got two functions again, and coincidentally the first one is quadratic, the second one is linear, and we are still subtracting and multiplying, but now there's actually a value for x that we're given. Okay, and so what we're going to do is substitute that value of x into the function, into each of those functions, and then subtract or multiply. Okay. Let's see. Yeah, I think we'll go through example 3 in this part 1 video. Alright, so this is another two-part example here. We want to find f minus g of negative 4. I'll write this out. Okay. So the notation is going to be the same. This just means that I need to find f of negative 4 minus, and then I need to find g of negative 4. Okay. And so guys, I just keep going. To find f of negative 4, I'm going to rewrite f, but I'm going to plug a negative 4 in for the x. And so if I do that, I'll have the negative 4, remember you want to keep it in parentheses, squared, minus the 5. And I'm going to keep this whole thing in brackets just to show that that piece is f of negative 4. And then we'll say minus, and then I'll keep in brackets g of negative 4. So now what I need to do is take negative 4 and plug it into the x that's in g. So if I do that, I'll have negative 2 times negative 4, and then I'll have a plus 3. Okay. Alright, so I've got all my substitution done now. So now what I can start doing is working inside these brackets. So negative 4 that's in parentheses squared is negative 4 times negative 4, which is a positive 16 minus 5. Okay. I'm just doing one operation at a time. Over here, in my second set of brackets, I need to do the multiplication before the division, or before the addition. Negative 2 times negative 4 is a positive 8 plus 3. Okay, and I just keep going step by step. Now in my first set, I've got 16 minus 5. That's going to be 11. And once you get each of these down to one number, you don't need to keep them in brackets anymore. And then over here, 8 plus 3, that coincidentally, that's also 11. And now, guys, we can actually finally subtract them. And 11 minus 11 is 0. Okay? So I can, okay, I've got enough room down here. I can restate this, and I can say that f minus g of negative 4 is equal to 0. Now I want to say that you could also have done this. You could first have subtracted the actual functions themselves and taken that resultant function and have plugged negative 4 in it. That will also give you 0. Okay, and that's a perfectly valid way of doing these if you want. But it would be extra work, I think, because you'd actually be subtracting these two. You get that new function, and then you would have to plug negative 4 into it. Alright, well let's look at the second part of this one. Here we're multiplying the two functions, and still x is going to have a value of -4. Okay, so I'm going to write this out again. We have f times g of -4. And my definition is the same. This just means f of -4 times g of -4. Okay. All right, so let's go back up here and look. So f is this quadratic, so I'm going to plug -4 in for it. So I would have -4 squared minus the 5. And again, I'm going to keep this in brackets. The reason I'm using brackets instead of parentheses here, guys, is because it's not good practice to use two consecutive sets of parentheses. You want to alternate parentheses and brackets. Okay, so because I'm using parentheses to encapsulate the -4, I'm then going to use brackets to actually encapsulate this whole expression. And then I'll say times, although you wouldn't have to. And then we'll do the same thing. We'll plug -4 into g. And so g is -2x plus 3. So if I do this, this will become -2 times -4 plus 3. And then you're going to do it the same way. You're just going to start evaluating inside each of these brackets. Well, guys, we did that already, didn't we? Up here. We know what each of these functions is when we plug in -4. They end up both being 11. So I'm going to skip those steps. I'm going to say that this one here would become 11 times the second one would become 11. But now instead of subtracting these two values, we're actually going to multiply them. And if you remember your multiplication tables, 11 times 11 is 121. And so we can say that, or restate that f times g, whenever x is -4, is actually 121. Okay, so guys, you're going to have several of these in your homework, and you'll be plugging in different values. Okay, so just take your time, go slow. All right, let's look at one last example from part 1 before we go to the part 2 video. So example 3 here. Here we're given two functions, and again, one is quadratic and the other one is linear. Okay, capital F of x and capital G of x. Well, it doesn't really matter that they're capitalized. But what we want to find here is f divided by g of -1. Okay, so we've seen a couple examples in which we were subtracting two fractions or functions and then multiplying two functions, but now we're dividing. So I'm going to rewrite this. This is f divided by g whenever x is -1. Okay, you can come back here and look at your definitions if you want. It just means that we'll have f of -1 over g of -1. That's what this definition is telling us. Okay, so I'll write this out. Capital F of -1 over capital G of -1. Now, of course, we want to make sure that this capital G of -1 doesn't become 0. Because if it did become a 0, then we would just say that we can't perform this operation, or that this operation is undefined. But I don't think you're going to see anything like that in your homework. All right, so what I'll do here in the numerator, I need to figure out what capital F of -1 is. Well, that just means plug -1 in to capital F. And so this would become -1 squared minus 20 over, and then I'll do the same thing for G, plug -1 in. You got to be careful here though, because this is 6 minus, and then you plug in the -1, okay? Now you may be wondering, why am I not keeping these in brackets like I did the others? Well, because they are separated. one function is entirely in the numerator and the other one entirely in the denominator. Okay, so for that reason I don't actually have to keep them, or I don't need to keep them in brackets. Alright, so we'll go about evaluating each of these. We're going to get a ratio, and then we'll see if we can do anything with that ratio. Well, negative 1 squared is 1. Negative 1 times negative 1 is 1 minus 20, okay, over. Now, there's only one operation down here in the denominator, 6 minus negative 1. You guys remember that subtracting a negative is the same as adding a positive, so that's the same as 6 plus 1. I'll go ahead and write that. And now we'll just continue. 1 minus 20 in the numerator is actually negative 19, and then 6 plus 1 is a 7, so we do get this ratio. You would go on and try to simplify this ratio if you can, this fraction, but this one, guys, we cannot. Okay, and so this will be the value of capital F divided by capital G whenever x is negative 1. It'll be this fraction, negative 19/7. Okay. All right. Now, real quick before I stop this first video, I do want to point out that sometimes you might be given, like let's go back to example 1 here. Sometimes they may ask you to multiply a function times itself. Okay, something like this. G times G, or G plus G. Well, you're going to proceed the same way. This just means you would take G of x and multiply it by another G of x. Okay, so what you'd be doing is really multiplying that function by itself. Okay, there is, I believe, an example like that, or a homework problem like that. And so here, you know, you could FOIL these out. You could end up getting a quadratic function. So I just want to point that out. You can multiply a function by itself, or add a function to the same function. Okay, there's nothing wrong with that. All right, so I think we're at a good stopping point. What we're going to do in part 2 is we're going to see, think about the lemonade example. So we have a cost function, we have a revenue function. We subtract the two, and we get a profit function. And so the question would be, well, we could figure out what the domain of both the cost and the revenue function is, but what would the domain of the profit function be? Or in the context of that example, if I come up with some function, we'll call it p of x for profit, what values of x could I plug into that function? Could I plug in like 1.5? Would that make sense? It would make sense if we're talking about cups of lemonade. I mean, I guess it sort of would. You could say, well, that means 1.5 cups. But typically you would sell it by the whole cup. Could you plug in negative values of x? Meaning that would indicate negative cups. Well, that wouldn't really make sense either, would it, in the context of that example? In fact, guys, you could really, the domain of that profit function would really only be your counting numbers. 0, 1, 2, 3, 4, 5, etc. Okay? It wouldn't be all real numbers. So that's what we're going to look at in the next video. When we do some arithmetic with two functions, we get this new function. And so what is the domain of that new function going to be? Can we just plug any number into it, or are there certain numbers we have to exclude? Okay. All right, so I will see you in part 2, and we'll finish up this section.